everyone, today I'm going to be doing the worked examples from Jacplus Year 12 textbook, so from 7.5, the applications. So let's start with worked example 12, and it's talking about a boy who has an ant farm and the ant population is changing at a rate of this equation here. And well, for a start, it says dn over dt, so that tells us it's a derivative function anyway, gives us a clue that we're going to be anti-deriving. But even if it didn't, it says the population is changing at a rate, so that would indicate that that is the derivative, where n is the number of ants in the colony and t is the time in days since the ant farm has been set up. Find a rule relating n to t if initially there were 50 ants. So, well, we can make a little table here and say, well, here is our dn over dt equation, which will be dn over dt equals 20e to 0.2t. And then we're going to have our n equation. And what we know so far is that initially, when the time is 0, there's 50 ants. So that's the information we've been given so far. So now I'm going to make the n equation, so n is going to be given by the antiderivative of 20e to the 0.2t dx, and that's going to be n equals 20 divided by 0.2, that's going to equal 100, e to the 0.2t plus c. And it's important that you have the plus c because we're finding an equation here and the c value is the constant. So we want to find out what c equals, and we can do that because we've been given this point. And you don't have to put it into a table, but it just kind of makes it nice to be able to see where that point belongs. Does it belong on the derivative equation or does it belong on the n equation? So it belongs on the n equation, so I'll sub that in. 50 equals 100. E to the 0.2, t is 0, plus c. 50 equals 100, e to the 0 is 1, and that means c equals neg 50. So that means that our equation of n, so n of t, is going to be 100 e to the 0.2t minus 50. So that's our equation, and hence the answer to, of course, part A. So our rule relating n to t. Part B, find how many ants make up the colony after 8 days. So they're asking how many ants. The original equation given to us, the dn over dt, that was the rate of the change. So that means how many ants is here. How many ants is given by n. So we'll just sub that 8 into that equation there. So let's do that. N of 8 equals 100 e 0.2 times 8 minus 50, and that's going to be 100 e to the 1.6 minus 50. And of course you would use CAS for this, so it ends up 445.3. So let's say, therefore, 445 ants after 8 days. Okay, let's move down. Oh, it's a bit small. So the next thing they're asking us to do, so we're asked to find the displacement as a function of t if initially the particle is at the origin. So initially the particle is at the origin, and when we're talking about the particle being at the origin, we're saying its position, so its displacement. So this is the picture that they give us in the book, and it says, well, displacement, or well, the position of the particle is usually given by x of t, and then if we derive that this way, we get the velocity, and if we derive the velocity, we're going to get the acceleration. So going back the other way to anti-derive acceleration, we get velocity, and anti-derive velocity, we're going to get to position or displacement. So in this question, we don't need the acceleration. I'm going to get rid of that. So we're just dealing with the velocity and the displacement. So we're trying to find the displacement. So we're trying to find this equation, x of t, when the velocity is this. So we're going to be anti-deriving it. So we can say displacement, which is x of t, is going to equal the antiderivative of velocity, which is t cubed minus t dx. So let's do that. X of t is going to equal 1/4 x to the 4 minus half t, or not x, be careful with that, squared plus c. And the c is very important because we have to find that. And we can't just assume that it's going to be 0. Often, if it starts at the origin, often you will end up that the c value is 0, but you do need to consider it. So this part here where it says initially the particle is at the origin, so this is talking about the position of the particle. It's initially, so when t equals 0, at the origin means that it's at 0 as well. So t equals 0 and our x of t is 0. So that means our point 0, 0, we're going to sub it in. And in this case, well, you're going to get that c equals 0. Whoops. But that's not always the case. So our equation is going to be x of t. What's going on? X of t, make sure you use the correct name of your function, x of t there, equals 1/4 t to the 4 minus half t squared. And of course, you don't need to write plus 0. So that would be our final answer. Let's go to the next one. There's a few of these. I think 3. So find the displacement as a function of t if initially the particle is at the origin. So same thing. So our this is our velocity equation, and our x of t, which is the displacement or the position of the particle, is given by the antiderivative of 2t minus 3 to the power of 3 dx. Now, this is one of those where we have to go 1 over 2 times 3 plus 1, 2t minus 3 to the power of n plus 1, so that's 3 plus 1, plus c. So you really need to know your formulas in your antiderivative there, 1/8, 2t minus 3 to the 4 plus c. And of course, we're still initially at the origin, so we will just sub that in, so the point 0, 0 again. So hopefully we have one where we're not initially at the origin, so we can see how that works as well. So 0 equals 1/8, negative 3 to the power of 4 is what, 81, positive 81 of course. So 0 equals 81 on 8 plus c. It's a weird value for c, but not impossible. And now, well, we've got our value of c, so therefore x of t equals 1/8 2t minus 3. Careful not to use x. It's certainly not x because x is here, the name of our function for displacement, minus 81 on 8. So that will be our equation for the displacement. Last one of those, and I'm just going to write this as v equals t minus 1 to the neg 2, because then we can antiderive that more easily. So x of t is going to be the antiderivative of t minus 1 to the neg 2 dx, and that means x of t equals 1 over 1, there's a 1 secret 1 in front of that, neg 2 plus 1, t minus 1 to the neg 2 plus 1 plus c. So x of t equals 1 over negative 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. Negative 2 plus 1, negative 1. So x of t equals negative 1 over t minus 1. Do not need the brackets there. Plus c. And of course, we now can sub in the point, we're still dealing with the same question where it's initially at the origin. So we still have that point 0, 0 on our displacement function. So we get 0 equals -1 over -1 plus c. That's going to be +1. 0 equals 1 plus c. C equals -1. So our final answer would be x of t equals -1 over t minus 1 minus 1. Okay, so those ones there, it's not really too hard. You just have to really watch out what you're dealing with. You're dealing with displacement, you're dealing with velocity, or, well, not here, but in other cases, acceleration, and you have to be able to work between the three. Let's go to the last one, I believe. Yes, the last one. The velocity of a particle moving in a straight line along the x-axis is given by this. So let's think we've got displacement, which is x of t, which goes to velocity, which goes to acceleration, and this is going to derive if we go this way, and further derive if we go this way. So if we go the other way, we are anti-deriving. So just like the picture, the more neat picture that I showed from the book up here, we're just going to use that. So it's the same thing. So where t is the time in seconds and x is displacement in meters. All right, so this is the velocity here. So I have this. And they even give us the bonus of telling us it's dx over dt. So even if you didn't remember that velocity is the derivative of displacement, they give you that clue right there. Show that the particle is initially at rest. Okay, so this we need to be careful because at rest means it's not moving, it's not going at any speed. So initially at rest means the velocity equals 0. So let's prove that. So initially, part A, initially means t equals 0. At rest means v equals 0. So we're trying to prove that the point on the velocity equation, so this equation here, we're not anti-deriving anything yet. We're trying to prove that that will equal 0 with that point. So look, let's do that. dx over dt equals 9 minus 9e to the -3 times 0. And you can probably see it already. 9 minus 9, e to the power of 0 is 1. So that's 9 minus 9 equals 0. So therefore, initially, particle is at rest. So we've subbed 0 for time into the dx over dt equation, and that equals 0. So that means the velocity is 0 when the time is 0, and that means the particle is initially at rest. So velocity is 0 when time equals 0, and that's initially at rest. Okay, find the equation relating x to t if it's known that initially the particle was 3 meters to the left. Oops, let me cross that out. Oh, it's not letting me change the colour. I'm just going to unline it. 3 meters to the left of the origin. So 3 meters to the left of the origin. So initially means time is 0. So we can say t equals 0. 3 meters to the left means that the position is -3. So our x of t equals -3. So left is negative, right is positive. So our point there is 0, -3. So we've got to find the equation of x to t. So we're finding the displacement, and the displacement is the antiderivative of the velocity. Sorry, did I write that in right? Yes, that's the equation. So let's do that. X of t equals 9x. -9 divided by -3 is +3, e to the -3t plus, whoops, not x, t plus c. Now be careful, you know, I nearly wrote a x there, and it's not x. You've got to be really careful because there's x, so you don't want to write it instead of t. In particular, you don't want to do that. That's really quite wrong. So be careful. So now we know we have a point, and it's not 0, 0 this time. It's initially the particle is 3 meters to the left, so 0 minus 3. So let's sub that in. -3 equals 9 times 0 plus 3e to the -3 times 0 plus c. That's 0 plus 3e to the -3 times 0, that equals 1. Minus 3 on both sides. So we've got our c value. Don't forget to state your final equation. And what is it? 90 plus 3e to the -3 minus 6. So this will be our final equation of relating the position of the particle for the position of the particle. Okay, so that completes the worked examples from 7.5.